Chemical reactions of amines. Amines are primary, secondary and tertiary amines. All these amines contains nitrogen atom and these nitrogen atoms contains unshared pair of electrons. Okay. Also there are NH bonds present in this primary and secondary amines. Okay. And nitrogen atom is more electronegative than hydrogen. Due to the presence of this lone pair of electrons and NH bonds present in the amines, they are highly reactive. That is, amines are reactive in nature. Okay, amines are reactive. Since the NH bonds present in different amines are different, their reactivity also varies. Okay, next point is, due to the presence of these unshared pairs of electrons, amines acts as nucleophiles. Okay, amines acts as nucleophiles. And these electron pairs, they can share these electron pairs to proton, okay, share their electron pairs or lone pairs, okay, to proton or Lewis acid, okay, or Lewis acid. So amines are basic in nature. Okay. First, let us discuss about the basic character of amines. Basic character of amines. Basic character. Okay. So amines are NH2 plus H plus HCl acid. Okay, Lewis acid. They can share their electron pair to hydrogen and the compound obtained will be RNH3 plus Cl minus. This is salt. Okay, salt is obtained. Due to this reaction, they are basic in nature. Also similarly, in the case of aromatic amines also, similar reaction takes place. Okay, and salt is obtained. NH3 plus Cl minus. Okay. Now, basic character of amines can be easily explained by the factor dissociation constant Kb or pKb. Okay, Kb or pKb. And this amines in combined with water in aqueous solutions, the alkyl ammonium hydroxide first obtained, okay, that gets ionized. And the reaction will be RNH2 plus H2O. Reversible reaction and form RNH3 plus OH minus, form ions. Okay. Now K will be concentration of products by concentration of reactants. Okay. So in aqueous solution, concentration of water will be unity. So OH minus by RNH2. Okay. So Kb will be equal to Kb dissociation constant will be equal to RNH3 plus OH minus by RNH2. Okay, concentration. Okay, this will be the Kb value. Now, what will be pKb? pKb will be equal to minus log Kb. Okay, so if Kb is greater, that means amines, those compounds are basic, more basic. Okay, compounds are more basic. And pKb, at that case, pKb value is less. Okay. For Kb is high and pKb is less, the compounds are basic, or the basicity of the compound is high. Okay. Now we can compare the different pKb values of different amines. First, these three are aliphatic amines, then ammonia, then comes aromatic amines. First three, we can see that as the methyl group or alkyl group increases, their pKb values decreases, which means that they will become more basic. Okay, but ammonia is having higher value, that means it is less basic than aliphatic amines. Now, in the case of aromatic amines, we can say they are having very high value of pKb value, which means they are less basic than aliphatic amines and ammonia. Okay, so from this we can conclude that as the methyl group increases, what will happen? There will be plus I effect. So in the case, there will be plus I effect, or they are electron releasing group. Okay, so they increases the electron density on the nitrogen atom. As a result, the electron pairs are easily available for protonation and the basic character increases. Okay, so in the case of ammonia, there is no alkyl group, so they are less basic. In the case of benzene, in the case of aromatic compounds, it contains benzene ring. Benzene ring is electron withdrawing compound. Okay, electron withdrawing, which is electron withdrawing, that means the electron density on nitrogen atom decreases, or due to minus I effect. Okay, the electron density on nitrogen atom decreases, which means that they are less available for protonation and they are less basic in nature. Okay, so this is in the case of gaseous phase. Okay, in the case of gaseous phase. So in gaseous phase, the order of different amines will be: primary is more basic than, less basic than secondary, which will be less basic than tertiary. Okay, this will be the order. Okay, so tertiary contains more number of alkyl groups, so they are more basic than the other two. This is in the case of gaseous phase. But in aqueous phase, other factors also determines the basic character. So inductive effect, then solvation effect, and sterric hindrance, all these factors determines the basic character of amines. Okay, so structure of the amines determines the basicity of amines. Okay, so let us discuss between alkanamines and ammonia. Okay, alkanamines and ammonia. In the case of alkanamine, on protonation, it forms RNH3 plus. Okay, NH3 plus. In the case of ammonia, it forms NH4 plus. Okay, NH4 plus. So from the structure we can see that this contains an alkyl group which is electron releasing. Okay, so this will be more basic than the structure of this alkanamine is more stabilized. Okay, than compared to ammonia. So it is more basic than ammonia. Now the next important factor is solvation effect. Solvation effect. Okay, as greater the size, lesser will be the solvation. Okay, greater size, lesser will be the solvation, lesser will be the stability. Lesser solvation and lesser stability. Okay, now let us draw the structures of different alkanamines. Solvation effect. Solvation of different alkanamines. First, in the case of primary amine, it can solvated with 3 molecules of water. So solvation is greater in the case of what? Primary amines. Now here compared to primary, solvation is less. Okay. Next, what will be in the case of tertiary amines? Case of tertiary amines like this. Okay. Or we can draw like this. Okay. So solvation, this will be the order of solvation. So solvation is less in the case of tertiary amines. So stability order will be like this according to the solvation effect. So lesser the stability means lesser will be the lesser basic. So tertiary amines are less basic compared to other two. Okay. Also we can see that this is bulkier group. Bulkier the group, greater will be the steric hindrance. Okay. Bulkier group means greater steric hindrance. That means that compound is less stable. Okay. This tertiary amine is less stable compared to other two. So they are less basic compared to other two amines. Okay. So resultant of all these factors, we can determine the order of basicity. Okay. Order of basicity of different amines will be, first let us take in the case of methylamines. Secondary will be more basic, okay, than primary, okay, which will be more basic than tertiary. This will be the order. Ammonia is least basic. Now, in the case of ethylamines, secondary will be more basic than tertiary, okay. Then comes primary, okay, NH2 plus, greater than ammonia. This will be the order of all the factors. When we consider all the different factors, this will be the order of basicity of different amines, okay. Now, let us compare between aryl amines and ammonia. Aniline. Aniline is weaker base than aliphatic amines and ammonia. Okay. Aliphatic amines and ammonia. This is due to the presence of electron withdrawing benzene ring. Okay. Here the lone pair of electrons in nitrogen atom, lone pair of electrons in nitrogen atom is in conjugation with benzene ring, okay, with benzene ring. So these electrons are not available for protonation, so they are less basic. Okay. Now let us see the different resonating structures of aniline. Okay, like this. NH2, this electron is in conjugation with the benzene ring. I discharge. NH2 plus. So nitrogen atom is having plus charge, which means that they are less protonated. They are not available for protonation. Okay. These are the different resonating structures. Next. Okay, these are the different resonating structures of aniline. Okay, so these electrons are in conjugation with benzene ring, so they are less basic. Now also, if it is protonated, we will get anilinium ion. Anilinium ion contains only 2 resonating structures, which means that they are less stable. So protonation is very less compared to aliphatic and ammonia. Okay, so only 2 resonating, as the number of resonation structure decreases, the stability decreases. So anilinium ion is less stabilized. Okay, anilinium ion is less stable compared to aniline, which means that protonation is not taking place here. Okay, so they are aniline is less basic in nature. Now what will be the effect of basic strength if substituents are present? First case, if electron releasing groups are present. Electron releasing group like CH3, OCH3, etc. This means they releases electrons. The electron density in nitrogen atom increases, which means that basicity increases. Okay, basicity increases in case of electron releasing groups like this. Okay, if electron withdrawing groups like NO2, electron withdrawing groups like NO2 is present. Okay, they withdraws electrons from the nitrogen atom. Okay, so what will happen? They decreases the basicity. Basicity decreases. Examples NO2, COOH, X, etc. X means halogens. Okay, so the order will be like this. See, NH2, NO2 is present, less basic compared to aniline. Okay, if electron releasing is present, more basic. Okay, this will be the basic order. Okay, the order of basicity of different substituted amines. Toluidine is more basic, para-toluidine.